Hypothalamus artificial intelligence, HAI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presence artificial brains applied in the oil and gas industries. That is the result of high research and disruptive modeling methodologies for Industry 4.0. The new way of mathematics is directly related to the parallel thinking, and today it can be said that like paper-based math, sequential mathematics for single-processor computers, will be in the short term a dead language. As in the human brain, in the future only parallel mathematical thinking will be practical. The new analytics is autonomous, parallel, and distributed. Oil and gas multi-problem models. OptX is the high optimization expert system which since 1990 has been handling multi-problem models. In 2009 Oil Express hired HAI for the design and the prototype implementation in GAMS of decision support systems for the optimization of energy resources. Integrated model made included production of crude oil, transportation of crude oil, oil and biomass refining, and transport of refined products. The project involved the design and implementation of an integrated model that links all steps of the supply chain of petroleum products, with emphasis on the consumption and marketing of the energy used by the network. HAI-OIL-EWO is the base to the formal implementation of the value chain model for Oil Express. At that time, the work developed was the birth of the concept of an artificial brain for the oil and gas industries. Artificial brains is based on artificial intelligence and mathematical programming integration. The artificial brain is the evolution of DSS under the Industry 4.0 revolution, that is conceptualized as a set of mathematical models, that exchange autonomously information between them, working online, using distributed optimization. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. The current state involves the integration of edge computing and cloud computing, to implement highly complex mathematical models. Those interested in knowing more about high artificial brains, can consult the LinkedIn article. Artificial brains, a swarm of mathematical programming algorithms. Oil and gas artificial brains. Oil enterprise-wide optimization integrates mathematical models for each of the links in the oil supply chain, in such a way to management the planning of the supply chain with a holistic vision. The design of HAI-OIL-EWO was the result of work done for a multi-business oil company. The union of models, and their coordination, forms the hypothalamus of an oil enterprise. The current computational power allows to model detail the supply chain, considering individually all the systems that compose it. This allows to visualize all the existing bottlenecks, and that affect the maximization of economic gains. Oil enterprise-wide optimization integrates mathematical models for each of the links in the oil supply chain, in such a way to management the planning of the supply chain with a holistic vision. The design of HAI-OIL-EWO was the result of work done for a multi-business oil company. The union of models, and their coordination, forms the hypothalamus of an oil enterprise. The current computational power allows to model detail the supply chain, considering individually all the systems that compose it. This allows to visualize all the existing bottlenecks, and that affect the maximization of economic gains. Oil supply chain holistic optimization. The oil and gas supply chain is made up of 4 links: upstream, midstream, downstream and retail. The links are connected by multimodal transport networks. The oil sector, a subsector of the energy sector, is composed of subsectors, links, that have strong interrelationships between them. The oil industry begins with exploration that aims to discover hydrocarbon reserves. After finding the oil and deciding if it can be extracted, the deposit is exploited to bring the hydrocarbons to the surface. The next stage is the transport of crude oil from the field to refineries or ports for export. Subsequently, through refining, the byproducts that represent the main use of oil are obtained. After transformation into derivatives, the final step is their distribution and marketing. The integral modeling of the production and consumption of energy resources, including the transformation of basic energy into consumable energy, has as its environment the planning decisions of strategic and tactical operations, which are made for the synchronization of the chain. Exploration. The first activity that starts the cycle of the oil industry is exploration. This stage is constituted by all those operations and methods that are used in the field with the sole objective of searching for oil, or geological structures favorable for its accumulation. Production, or exploitation. The raw material of the production sector is the reserves discovered by the exploration sector. To determine the optimal production policy, production costs, losses in reserves and capital investments in drilling new producing wells, in maintenance of facilities, and in the operation of fields must be considered. A production sector optimization model aims to determine the optimal amount of crude oil that should be produced in a field, in each period of the planning horizon. Refining. The refining industry aims to obtain from petroleum a range of products of well-defined quality, ranging from light gases, such as butane and propane, to heavy fractions, fuel oil, asphaltenes, and intermediate fractions, gasolines, kerosene, diesel, lubricating oils. The transportation and distribution of crude oil and its derivatives, whether liquid or gaseous, is an important phase of the oil industry. For this purpose, multimodal transport systems are used, consisting of pipelines, steel pipes, oil and gas pipelines, and vehicles, barges and tankers, tank cars, railways. Trading. From an industrial point of view, the marketing of crude oil and its derivatives is carried out through two markets: free spot market transactions, and long-term bilateral contracts, and derivative financial instruments. An important aspect in the oil market is related to the blending of oils of different technical characteristics, in order to adjust in the best way to the standardized commercial oils that are traded in the market, and to the specific characteristics of the crudes consumed in the refineries. Energy. The industrial processes developed, along all links of the chain, consume energy in various forms and in large quantities, so that, at the wholesale level, a producer of refined products is a major consumer, and/or producer of energy. At the same time, some links in the chain provide equally important energy resources that can be transformed or reused as part of the energy consumed. Additionally, depending on volumes and technologies, a producer could act as a net producer of energy in the electricity, gas and biofuels markets, which have important peculiarities for the agents acting in them. Due to the incursion of biofuels as a necessary alternative to manage the problems of dependence on oil and environmental pollution, these products are henceforth considered as a complementary part of the supply chain of petroleum products. Decision-making. To ensure optimal decision-making at the level of a holistic strategy and tactics, the system must be considered, synchronizing the different links in the chain, in space, functions and time. The management of the complete oil supply chain must be based on the integrated optimization of the different links. It is one of the main research topics worldwide, due to the importance and impact of the products it handles. The support of this type of planning is complex and therefore turns out to be a perfect field for the application of optimization tools, mathematical programming, in order to support decisions that allow the optimal coordination of the holistic supply chain. Mathematical framework. The oil supply chain is the sum of facilities plus products that flow through the network that interconnects the facilities. For ease of structuring the models, the framework is followed, consisting of macro installation. It is associated with a sector, a link, in the oil chain and is made up of facilities that together integrate the production system associated with the macro installation. For each type of macro installation, a generic model is developed that allows the planning of the macro installation considering the exogenous boundary conditions, in space and time, the supply of raw materials and inputs to be consumed, and the demand for final products that must be processed by the facility. A macro installation is made up of multiple installations, or facilities, defined as installation. It is associated with a productive unit that is part of the productive chain that is carried out in the macro installation. The facilities, installations, vary depending on the link to which each of them belongs. The image presents an example of a refinery, which is composed of 5 facilities. Normally a macro installation is integrated by two types of industrial plants. Industrial process plant, where the processes of transformation of matter, raw materials and inputs, into finished, or intermediate products are carried out. And industrial services plant, where the transformation of energy sources is carried out, to meet the different forms of energy required by the process plant. The modeling of the two industrial plants can be done in several ways. Ignoring dependency between plants, and synchronize them with good practices. Coordinate the two models, generating dependence on the industrial services model, that responds to the independent optimization of the process plant, meeting the demand for services in an exogenous manner. This is the most used modeling approach. And integrate the two models into one, which will produce the greatest gain, both economic and environmental. The solution implies the optimal balance between the demand and the offer of industrial services. This implies endogenizing the demand for industrial services, which will be determined by the integrated model. In HAI-OIL-EWO, the following types of macro installation are considered. Industrial facilities, where the processes are carried out, production and refining. Agricultural facilities, where the reproduction processes and development of agricultural products with high biomass content are carried out, and transport systems, they allow products to be transported between industrial facilities and consumption centers. They are conceived as the integration of pipeline systems, oil, gas pipelines, and polyducts, with multimodal transport systems through vehicles. Like process plants and service plants, it is necessary to decide how the modeling will be done, independent, coordinated, or integrated. The model's integration entails the endogenization of all border conditions, offers and demands, which allows the oil company-wide optimization. Following the laws of transitivity of algebraic models, if all macro installation models are based on mathematical programming, a super-optimization model, that represents the entire supply chain of a large company, can be generated following the principles on which artificial brains are based. From functional modeling, based on generic models for each type of macro installation, it must be passed to the parameterization of each physical macro installation. This setting can include restrictions that apply to a specific installation. Connectivity between macro installations is done through terminals, sites for storage and blending of products. This concept, similar to that of superstructures, makes it possible to connect supply chains with an unlimited number of macro installations. The terminals are linked to transport modes, allowing the flow of multiple types of products between macro installations. Each transport mode is associated with a generic model, and together they must attend the transport services demand to meet the demand of final products, in industrial markets and customers. All the facilities that are part of a company must be integrated through artificial intelligence models that represent them, in such a way that they holistically optimize planning and scheduling of the activities. This applies to physically connected supply chains, or to global chains that are linked through financial resources, human resources, long-distance multimodal transport systems, and markets. The models of a region will correspond to the models of the macro installations that operate in that region. Under the concept of integration of models, it is possible to have models that make up the different regional hierarchies of the organization. Hierarchical coordination of planning tools. It is traditional to organize decisions hierarchically into strategic, tactical and operational. The operational decisions are divided into the scheduling and advanced optimal control. However, due to the technological progress generated by Industry 4.0, mainly in relation to smart metering systems, nowadays we can talk about a new type of online optimization modeling, real-time distributed optimization. From the point of view of mathematical modeling, hierarchical levels are intertwined and coordinated through the boundary conditions in time, and common modeling that can be shared. The modeling strategy of HAI is that all models of a decision support system can communicate with each other. Under the principle of transitivity of algebraic formulations, models grow in complexity, as they descend from the hierarchy of decisions. All models share equations, mainly those related to the physical process. Therefore, they can be made in a continuous modeling process. The models of higher hierarchy will be more aggregated, in order to cover long periods of analysis, of the order of the years. The emphasis of the model should include the interpretation of the economic and technological future, so it is appropriate that they are stochastic optimized. As the models approach real time, the level of detail increases, and the planning period decreases, the most important being the engineering representation of the process. The table, elaborated by IBM, shows a resume of the optimization solutions for oil and gas enterprises. The matrix of models is organized by levels in the chain, and by hierarchical levels of decisions. HAI-OIL-EWO meets all the software solutions developed by HAI, in different areas of application of mathematical optimization models, oriented to planning and to scheduling operations, in different business of the petroleum products supply chain. To ensure optimal decision-making at the level of strategy and tactics, the system must be considered, synchronizing the different links in the chain, in space, function, and time. The management of the complete oil supply chain must be based on the integrated optimization of the different links. It is one of the main research topics worldwide, due to the importance and impact of the products it handles. The support of this type of planning is complex, and therefore turns out to be a perfect field for the application of optimization tools, mathematical programming, in order to support decisions that allow the optimal coordination of the holistic supply chain. Large-scale optimization and artificial brains. One of the fundamental ideas of the artificial brain is the atomization of the system, bottom-up approach, to integrate multiple mathematical models, using the framework of large-scale optimization methodologies, like multi-level Bender's theory, and Lagrangian relaxation. Given the complexity of the real world, which involves mathematical models of all types, linear, nonlinear, discrete, continuous, convex, non-convex, etc., it cannot be thought that with a single methodology, all the problems that make up an artificial brain can be solved. Therefore, it is required to have access to multiple large-scale optimization methodologies, which, using the principles of cross-decomposition, connect all mathematical problems, to perform autonomous distributed optimization in real time. Making high-complexity large-scale mathematical models without programming. The algorithm that simulates the hypothalamus is assembled by Optex, the HAI's artificial intelligence, using the models that traditionally make up a decision support system. Making high-complexity large-scale mathematical models. The best way to make software is having to do it, is the goal of Optex. The HAI approach is aimed at developing cognitive robots that eliminate the tasks of computer programming, since the robot takes care of this process. This enhances the mathematical modeling capacity of the professionals. Those interested in knowing more about Optex can consult the article linked in. Optex, the exocortex for mathematical modeling. Supermodels for super supply chains. Integrating all models of a large supply chain will result in greater complexity in mathematical modeling, and increased computational resources consumed by models, including programmers, and greater value added by mathematics, that is, greater return on investment. Making very large-scale models by the traditional way, using a computer programmer, it is an impossible way, because the programmer only can write a limited number of lines of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process. Considering that Optex is a cognitive robot, that implies that Optex is able to produce infinite lines of perfect source code per period. Optimizing the oil value chain. HAI-OIL-EWO meets all the software solutions developed by HAI, in different areas of application of mathematical optimization models, oriented to planning and to scheduling operations, in different business of the petroleum products supply chain. HAI Oil Sand Op, Oil Supply Chain Optimization, Sales and Operations Planning, integrates models for each of the links in the oil supply chain, in such a way for the planning of the chain with a holistic vision. The design of HAI Oil Sand Op was the result of work done by HAI for Oil Express Multi-Business Oil Company. The table presents a summary of the oil production mathematical optimization models developed by HAI. The table presents a summary of the oil transport and blending mathematical optimization models developed by HAI. All models developed by HAI, to support decisions in the oil industry, our interconnected trough and information system. In this way, the construction of artificial hypothalamus is a question of joining the equations that make up the different models. Those interested in knowing the specific models developed by HAI can consult the article linked in. Advanced Analytics Solutions for Oil and Gas Industries. Like Herbert Simon, hypothalamus artificial intelligence believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.